So in the previous videos in this series I started assembling my Curta calculator, all 3D printed apart from a few of the fasteners and a few of the springs. And as I said previously, this is by courtesy really of Marcus Wu, who took the original design drawings and turned them into 3D printable format. And had the usual complaints, I'm going into too much detail, that sort of thing. But this video series is not just about assembling the calculator, I'm trying to explain how it works. So if what you want is just the assembly guide, then I suggest you go and watch Marcus's video. He posted a very good video on just the assembly. He doesn't explain how it works. What I'm trying to do here is explain how the calculator works. If you're not interested in how these work, then just don't watch the video. But I will be going into quite a bit of detail, especially once the calculator starts really coming together. And like I said, if you're not interested in that, that's fine, just don't watch the video. But the stage we're at now is the core of the calculator is assembled, and what I'm doing now is putting in place the drive shafts and carry levers. So all the drive shafts and gears are in place, and the real key to this working, as I've said previously, is cutting down friction. And towards that end I've been experimenting with various spring tensions. Now in the build manual it says use 0.6mm piano wire for the carry lever springs. So that's what I did for the first few. This is really just by way of experimentation. I may select all one or the other. So the first ones are 0.6mm. And the springs perform two real functions in this particular usage. The first thing they do is they hold the carry levers in whichever of the two positions they're in. But they also complete the transition into that position, which is a bit harder to show. So I'm going to just zoom the camera in and try and explain the secondary function of the springs, and it should hopefully make more sense as to why we need to keep the friction down. So we've got the carry lever here, and it will be in one of two positions. It will either be in this lower carry position or it will be in the upper position. And like I said, as well as the spring holding the carry lever in place, it also has to make sure it fully moves to the proper location. If it goes halfway and stops, then all bets are off and something weird could happen. So this might be difficult to show, but if I start moving this and I just very slowly push the lever across, at some point, hopefully you can see it popped across on its own. So the file's no longer touching the lever. And it should do the same thing going the other way. So if I start to slowly push it back, at some point, as you can see, it pops the rest of the way. And that's the secondary function of the spring. It's to hold the lever in place, but also to make sure that it goes all the way into either of the two locations. And one of the problems with the stiffer spring is, these are the stiffer spring up here. The one we just looked at is the 0.4mm piano wire. These are 0.6. Is to get the force low enough, you have to kind of leave the spring a bit loose. So this is not really, it will probably work, but it's not really ideal. It's not going into its exact location. But if we move the spring all the way in so it positively locates, it takes quite a bit of force to move. Now the thing with springs in mechanisms like this is that if you've got a bit too much friction, then you need a stronger spring to make sure that the part moves properly. But having a stronger spring increases the friction, so you kind of get an issue where you end up with a lot more friction than really you want because you're trying to overcome the friction. So I've been working quite hard to get the friction down. In fact, since the last video I've completely dismantled this, cleaned up some of the shafts, some of the bearings, and reamed the bearings out slightly more. I also machined the face that these gears sit on, so this recess the gears are in. The bottom of it is a 3D printed part, of course, 3D printed top surface. And it was fairly uneven. It wasn't horrendous, my printer's quite good, but even so it was a bit uneven. So I took the time, put this in the lathe, machined that surface so it's nice and flat and smooth, and then went through all the rest and everything now spins very freely. There's pretty much no force required to spin these at all, and that's really how you need to get it working to keep the forces down, otherwise you'll encounter problems further on. But there should be no resistance to turning that's noticeable at all. Same with the levers, they must pop from one location to the other. This is taking almost no force at all, it's taking the gear with it, so you need low friction between the gear and the shaft. If it's not doing that, now's the time to get it sorted out. These blocks really help because they kind of stabilise the entire thing and give the lever a good solid foundation to work on. So I've been going through fitting the levers. I'll show how I'm fitting them, just do one, I'm not going to bore you showing the whole lot. But I've been going through polishing up the levers, so I use 800 grit and then 2500 grit, and the most important faces are along these edges. If these aren't smooth, the lever won't slide cleanly inside its bracket. So if we take the guide it's going to go into, make sure it's the right way around, and that goes on there like that, and we need to make sure this is very free to slide in this guide, which hopefully you can see it is, but you better feel it if it's not. It needs to slide with pretty much no resistance whatsoever. We then take a spring. As I said, I've been experimenting with springs, so I've got either 0.6 or 0.4mm wire. I'm using 0.4 for most of them. I might need to come back and change it later, but we'll try this for now. It seems a lot happier with the lower resistance spring force. So this thing goes on here. We now have to put this down and engage it with the gear, and it sits in these two slots. I've also polished up the face of the slots where it butts up against the sliding lever. So I'm trying to work around the camera here, but these go into these two slots and also engages with the gear. Now I certainly can't see this, I'm trying to get this in a place where you can see it. I'll try bringing the light further down. What I'm going to do is put this end of the lever into the gear, down into the tens bell, and at the same time engage these two sections in these two slots. Make sure the spring is in its little slot, and it's kind of pinched between these two cheeks, and that's what holds the spring in place, and then this should slide down into position fairly easily like that. And then once it's in, you need to make sure it works properly. We can adjust the height or the position of the guide. It will slide up and down a little bit. There's a bit of adjustment, not a huge amount, but make sure it's going to click into one of the two locations, and that in the bottom location the gear, this actual gear, needs to line up with the tooth that's on the tens bell. So once we've done that, we can take one of the little blocks. If you're not using these, the screw just goes in and the head of the screw holds onto the guide, but as I said, I prefer to use these, so I'll put one of these in. That then screws in. Now the threads may seem to be at a strange angle, but the screw needs to be parallel to the face of the guide. Once I've got the screw started, I can push the block down. That will engage with the, oops, sorry, move the camera there. That will engage with the lever. Screw it all the way in. Now make sure the screws you use aren't too long, because these holes do go right through to the bearing holes that the shafts run in, and if you go too far of course you'll pinch the shaft. So keep going. At some point you'll pinch the guide. This is still moving a little bit with a bit of force, so we're almost there. Make sure we're in the right position, and then a final fraction of a turn, and that's all we need to do. So I've got another, so look, another 8 to do, and then I'll get back on camera and we can start fitting the other components. So that is all the carry levers set, including the 5 for the counter register. I've checked to make sure they all move freely and that they're all aligned properly, and they seem to be working fine. What I'd really like to do, of course, is actually rotate the calculator to see if it will spin. But if you've ever worked on a mechanical calculator, then you'll know that unless everything's in the right place and can turn freely and will do what it's supposed to, it's very easy for them to jam up. And the same is true of this. This is, of course, just a mechanical calculator, so if everything's not doing what it's supposed to and we try and rotate it, we could break something or it will just jam. So we're a lot safer now than we were because we've got all the carry levers in place, and that holds the gears at the top where they should be. We're not too bad with the input gears. They don't really need to be in precise locations, of course, because they could be in different positions depending on the number we are trying to feed in. But we do have the reversing gears that we need to take care of before I risk trying to rotate the machine. So the reversing, I'll come back to the function of the reversing gears later, but what we need to do is fit this device, and it engages with these gears. So we have 6 gears we need to fit into these 6 slots, and then there's a shaft that runs up through it and some spacers. There's also a spring and a detent ball that need to be fitted so that this will kind of click between 2 distinct positions. But to make sure that everything's running smoothly and there's no binding, I'm going to try fitting it first without the detent spring and ball, just to make sure that this moves freely. It's a lot easier to tell when there's no detent in it. So we'll get this fitted and see if it actually moves. Once this is in place, we can actually risk rotating the calculator and see if it actually turns freely. So the way we fit this is there's a cutout in the shaft at the bottom, and that goes through this slot in the bearing plate. Ultimately the shaft will slide upwards. This wider section will engage in the bearing plate, and then we can put a nut on the top. But the tricky bit is getting all 6 gears lined up so that they will fit into this guide. So I may have to do this off camera, but I'll give it a go first. Try and get them all lined up. Okay, well that's all 6 gears in the plate, so we'll try sliding this up. Okay, so if everything's working the way it's supposed to, this should actually move, which it does. It moves nice and freely. And it's taking all 6 gears with it. As you can see, almost no friction at all. So I'll take this back out, we'll put the detent spring and ball in, and I'll refit it, fit the nut to the top, and then we can actually try rotating the calculator. Okay, that's the reversing selector installed. I did remember to fit the spacers. These just control the throw of the lever, so it goes from one position to the other without overshooting. And then the detent ball makes sure it sits in the right location once you release the lever. And that moves nice and freely, does what it's supposed to, and in theory, in either position we should now be safe to rotate the calculator. So I haven't tried turning it yet, other than before I started fitting the drive shaft, so I don't know how free, if at all, this will turn. It's in the home position, so we'll try and give it a spin and see how tight it is. Okay, so it's coming out of its home position. Everything is still free, there's nothing binding yet. What I'm going to do is just move it bit by bit and make sure nothing binds up. I'm just feeling the drive shaft to see if any are catching on anything. As long as they're all free to move slightly, then we're safe to continue. What I don't want to do is break anything by putting too much force on this. Okay, still looking good. Okay, we're past all points where it can bind up on the reversing mechanism. And it's just now the input gears that have been turning, so we'll keep rotating it and it should go back to the home position, which it does. So it's now in the home position. Turns surprisingly freely. It's there's no real resistance to turning it at all, which is quite a surprise. Okay, good. So that appears to be doing what it's supposed to so far. The next thing is to fit the input selectors, and that's these. And these work in a fairly simple way. I've gone ahead and fitted the screw detent ball and spring. I've been experimenting with spring lengths on these as well to try and get the feel right. I think this one's still a bit on the tight side, so the idea is that the detent ball sits into one of these little dimples, and that will allow it to sit and properly select one of the positions from 0 through to 9. But it's really getting the feel of this right, so that it'll be nice to use and not too tight or too loose. If it's too loose, this will kind of move up and down. It won't positively select the required digit. If it's too tight, it just won't be nice to use, or it will break something. But this seems reasonable. That's a bit on the tight side, but I'm going to try fitting this and see how we get on. So this key's, there's a slot in the inside of the wheel, and then this flat section on here which engages with it. We'll go in, of course, one of two ways around it. We'll go this way or that way, and we can tell from the position of the lever that this is not 8, it's 3, so we'll make sure that's fully pressed in. Find our first position, which is this one, and then to fit these, there's a pin at the top, and that fits in a small hole at the top, and then there's a bearing piece that pushes through the bottom of the bearing plate and into a small hole in the bottom of the shaft. And at the same time, we have to make sure that the fork selects the actual gear. We can push the bearing pin all the way in. Okay, and then we should be able to select whichever digit we want, and it will move the gear into the appropriate position. Actually, the spring might be okay. It feels a lot better once it's in the machine. So it goes all the way from 9. This would normally show through the slots on the outer cover, and 9 at the bottom and 0 at the top, which is correct. And it is, of course, moving the gear into the correct location. So it's looking good. I need to now install the other 7 of the input selectors. I've only so far prepared 2 of these indicator drums, so I now need to go and do the rest. so it'll take a while, but once that's done I can install the other 7. I've then got the 2 bearing plate pieces, and these just sit on the bottom. There's a couple of screws that hold these in place, and this is just to stop these little bearing pins from dropping out. So I'll get the rest of the input selectors installed, I'll get the bearing plates installed. That will then be this piece pretty much done. The calculator's in 2 main sections. We've got this piece, and then we've got the carriage that sits on the top. So I'll get this piece finished off, we'll have a quick look at it so you can see how that looks, and then we'll move on to the carriage. So that's all the input selectors fitted. I've checked that they all slide nicely. On the first one I've actually bonded the digit wheel and the shaft together so they're one solid piece, and it seems to operate much more smoothly. It's much nicer. These aren't too bad, but they do kind of flop around a little bit because of the join between these 2 parts. So I'll do the same thing to the other 7, and these all work very nicely. I can select the input number as I want, and I fitted the bearing plates, and the calculator, or this part of it, now spins nice and freely. So you can see the gears turning based on the numbers that are selected. Back to the home position. So that's that part now complete. Reversing knob moves nice and freely as well. So it's all working the way it should. If I try pushing the carry levers down, then they do pop back out, and they seem to be doing exactly what they should be doing. So that's it for this piece. We'll put this to one side, and in the next video we'll assemble those pieces into the carriage.